Start.
Good afternoon, everyone. We are a team of three people from institution Elective, and our topic is high entropy oxides as advanced electrode materials. The introduction for this topic is since traditional oxide materials have been widely used in various applications, such as catalysis, energy storage, thermal barrier coatings, like single or binary elemental compositions, structural instability under harsh operating conditions, limiting tunability of properties and trade-offs between competing properties. That's why the concept of high entropy alloys has inspired the development of high entropy oxides, where five or more metal cations are stabilized in a single phase crystal structure due to high configurational entropy. And we have taken these eight 7 to 8 literature survey from the recent years 2023, 2022, 2024. Two of them are from 2024 and three of them are from 2023 and one is from 2022. uh, our problem statement is the demand for high performance and long lasting and sustainable material that can be used as a replacement for batteries, which has high synthesis complexity, and the predictability is good, and to fill the performance gaps as well, and with high scalability. So that's why we are using this solution regarding high entropy oxides that have better energy density and power density compared to the conventional battery system. And here is the objectives.
So the objectives are to explore the structural and electrochemical properties of high entropy oxides relevant to the battery electrode applications, to analyze the recent synthesis technique used to prepare phase stable and compositionally uniform HEOs, to evaluate the performance of HEOs in anode, cathode, and solid electrolyte holes across various battery chemistries, to identify the current challenges and propose future directions for the practical implementation of the HEOs in renewable energy storage and system. Now we come to the existing system versus proposed system. Next slide. Existing method and limitations. Conventional electrode materials rely on one or two metal rely on one or two metal cations. Example: LiCO O2, LiFePO4, limiting compositional flexibility, suffer from structural degradation and phase separation during charge and discharge cycle, exhibit moderate electrochemical performance with limited capacity and stability at high rates, establish synthesis method but not easily adaptable for complex positions. Ion transport is often hindered due to less defective rigid crystal structures. Environmental concerns exist due to the use of scare or toxic elements like cobalt. Proposed system composed of high principal cations established and stabilized by high configurational entropies, show enhanced structural stability and resistance to degradation over long cycles, deliver high specific capacities and better cycling rate performance than traditional materials, utilize flexible and advanced synthesis method, lattice distortions and high defect densities, improve ionic conductivity and diffusion, offer potential for eco-friendly design and use of more abundant elements.
Next slide. So the methodology for our project is we started by reading recent research papers about HEOs and batteries. Then we studied different ways to make HEOs like Soldier and combustion methods. We reviewed tools like XRD and SEM to understand their structure and conductivity. Next, we looked at how HEOs perform as battery materials compared to traditional ones. Finally, we found the current challenges and gave ideas for future improvements. Now, I'll tell you how this impacts society and what is the key applications for our project. So, HEOs can be used in next generation lithium-ion batteries. They help batteries charge faster and last longer. They can also be used in solid-state batteries, which are much safer and store more energy. HEOs hence are great for storing renewable energy like solar or wind power. They are also useful for electric vehicles by solving issues like slow charging and battery aging. For the societal benefits, HEOs help support clean energy. They reduce the need for rare or toxic metals. They make batteries safer and more reliable, and they help the world move towards sustainable technology. In conclusion, high entropy oxides are a big step forward in battery technology. They are more stable, perform better, and are safer than traditional materials. With more research and better production methods, HEOs can help power the future of clean energy. For the future scope, in the future, we can use AI to quickly discover better HEO materials. We also need to find cheaper and greener ways to make them. HEOs can be used not just in batteries, but also in fuel cells and supercapacitors. We can improve how they connect with other battery parts using surface changes. And to make them ready for the market, we need to focus on long life, low cost, and recycling. Thank you. So this was our project.